be using OpenIntro and Google Colab to begin the process of data management. So first we want to go to the data repository for the course, which is the OpenIntro data repository. I'm just going to Google OpenIntro data and that'll take me right there. This is our data repository for the course. It's associated to the textbook, and you can see we have a whole bunch of data here. I'm going to select this one, ACS 12. Now, we have links to various formats of data here. We have CSV. We're going to want the CSV. If I click this, I will see the CSV file. That's not generally what we want. What I'm going to do is I'm going to context click that, option click, right click, whatever. I want the menu to pop up, and I'm going to copy that link. That's a link to a CSV file, which is a text format for data management. Next, I'm gonna, with that in hand, I'm gonna go to colab.research.google.com and I'm gonna create a new notebook. The title of the notebook will appear at the top and it'll appear as Untitled. So let's give it a sensible title here. So beginning data. You can see that the Google Colab notebook opens with one code cell ready to accept commands, and we're going to start with the command import pandas as PD. This command will load the pandas statistical processing package for us. I'm executing that command by pressing Shift-Enter on my keyboard. We can also execute a command by pressing play. After a few seconds, the virtual machine is created, the command is executed. It gives us no feedback, but it has done something. It's loaded the statistical processing package. The next thing that we're going to do is we're going to tell Colab to go out there and fetch the data. Now, where is the data? It's here in the OpenIntro datasets, and I will remind you here, I have copied the link to the data into the copy buffer there. So what we're going to do here is we're going to go to the next code cell, and we're going to use the wget command, which is for webget. It has to begin with an exclamation mark, so that's important. Exclamation WGET. And then I'm going to paste the URL that I copied. That's the URL which refers to the dataset itself in the CSV format. I'm pressing Shift-Enter on my keyboard to execute that command, and it will execute and download. What that has done is that has downloaded the file into the file resource for the Google Colab notebook and stored it as the file acs12.csv. The next thing that we're going to do is we're going to read the file and create a data frame from it. The data frame will need a name. We might as well call it DF. That's a fairly boring name that is appropriate to any data frame. Now the data frame will be created by PD, and particularly by PD's read CSV command. The read CSV command needs to receive the file name in quotes, acs12.csv. And so we'll type pd.read_csv, parentheses, and then in quotation marks, the name of the file. Pandas will understand how to find this file because it's already been downloaded by wget, right? So wget went out onto the internet to fetch the file and download it. It's now in the local file resource for the notebook, and then pandas will read that file. Shift-Enter will execute this command. And again, we'll get no particular feedback here, but something has happened. What has happened is that file has been read and its contents have been stored in the format of a data frame so that pandas and Python can read them. And that data frame has been called DF. It's been assigned that name by our choice here. We could have called it anything we like. If we would like to look at it, we can simply type DF on its own code cell and Shift-Enter, and we'll get a view of that data frame. Notice we've got all the cases down this way. It looks like there are 2,000 rows, so there are 2,000 cases. And we've got all the variables across here. We've got a whole bunch of variables in this data frame here. If we want to stare at this, we can stare at this, but usually we want to do something more sophisticated. We want to do some sort of computation, some sort of statistical management. There is a default first command that we can be using on these data frames, and it's called describe. The describe command will compute all descriptive statistics for this data. So what I'm going to do here, I'm going to change this command so that instead of just df, it says df.describe. Now that's the name of the command, but in order to execute that command, I need those parentheses, a left parenthesis and a right parenthesis, right next to each other with nothing in between them. They are important in this context. Now if I do this, Shift-Enter on this line, then Pandas will go and calculate all of the basic quantitative descriptive statistics about all of the quantitative variables in that data frame. Now I remind you, a lot of the variables in that data frame were not quantitative. Like gender, for example, is a categorical variable, and citizen is a categorical. And a lot of these are categorical variables, but many of them are numerical quantitative variables. And Describe has calculated basic statistics on them. So for example, the mean or average age is 40 in this data set. The mean time to work is 26, which might be a 26-minute commute time. If you want to know exactly what this means, you have to go back to the data manifest here, click on the open intro data management, and then you can, let's see, time to work here, then you can find the meaning of all of this data from the data manifest. So this tells us the average, the median, the min, the max, the count, and the standard deviation for all of the quantitative variables that appear in the data frame. And so, of course, it's a very useful command. The last command that I want to illustrate here is the core command, which calculates correlation coefficients. Let's execute it, and then we'll see if we can make sense of the results. So the core command calculates correlations between variables. It gives numbers which are between -1 and 1. Often we get numbers that are close to 0, like this one, for example, is close to 0. If a number that comes out of a correlation is close to 0, it sort of suggests there's no particular relationship between these variables. So this number close to 0 indicates there's probably not much relationship between the time to work variable and the income variable, which might actually be a surprise, or maybe not, I don't know. However, this number is positive and not too close to 0, and this indicates that there is some sort of relationship between the hours of working and the income. Maybe it's not surprising. It seems to suggest that if you work more hours, then you might have a higher income. Or if you have a higher income, you might work more hours. So there seems to be some sort of correlation here. Some of these are 1. That's because there is a perfect correlation between any variable and itself, right? So age versus age, those variables are perfectly correlated. The older you are, the older you are. It doesn't really mean anything, but that correlation will be indicated as a 1. So these 5 commands help us get started on any data frame at all. Open pandas as PD, get that file, produce a data frame from that file, describe, and sometimes the correlation coefficients.